fans meet real testing. Designed with EDF-Generator.com, created, tested and improved step by step.
Welcome back. Today we start phase 1 of our EDF fan tests. We'll begin by checking how the number of blades affects thrust and efficiency, then explore the diameter to see if larger fewer blades or smaller, more numerous blades work best. Next, we'll test different sweep angles to understand airflow effects, followed by root and tip cord lengths to find the balance between long slender blades and short wide ones. Finally, we'll look at design speed, adjusting blade angles to match the incoming airflow. Step by step, we'll build the knowledge to optimize a fan performance. Let's dive into phase 1.
So, without further ado, let's start with series 1 of phase 1. Here we are testing how the number of blades influences the thrust of our EDF fan. We'll begin with a baseline design and then print versions with different blade counts, starting low and gradually increasing. Each fan will be tested under the same conditions so we can directly compare its thrust. Now, an important note about the measurement setup. I am using a bending beam with strain gauges to record the force produced by the fan. This beam has been carefully calibrated with weights, so the readings are accurate. However, because of the airflow also reflects off the beam itself, part of its thrust is lost. That means the real thrust is slightly higher than the measured values. The key here is comparison. Even if the absolute thrust is a little bit lower, the relative differences between the blade counts are still clear. By the end of this series, we'll know exactly how blade count affects our setup, and we'll be ready to move on to the next parameter.